Welcome to today's movie. In today's movie, we're going to look at the non-parametric test, Mann-Whitney U test, that we can use for two independent samples. And in this particular movie, we're going to look at how we solve it using Excel. So what we have is example 8.7 in the book, and you can see the data on the screen. And this is about a company is considering adopting a U method of training for its employees. To assess whether the U method improves employees' effectiveness, the firm has collected two random samples from the population of employees sitting the training assessment. Training type 1 employees have studied via the traditional method, and training type 2 employees via the U method. So you can see the scores on the actual system. So what we want to do is we want to analyze this data, and we want to see whether or not there's a performance change. So the step one, the hypothesis test, the null hypothesis is no improvement in performance. So median 1 equals median 2. The alternative is that the performance has changed. So median 1 is not equal to median 2. So we have a two-tailed test because it's not equal to. So remember, type 1 is where they do the test where they use the traditional method, and number 2 is where they use the U method, and you can see the scores here. So in total we have 100 students where their results have been recorded. So we want to ask that particular question. Now, because these are related, because these are independent of each other, then we use the Mann-Whitney U test. Okay, so we have step 1 to state the hypothesis. Step 2 is select the test, so it's going to be a Mann-Whitney U test. Step 3 is select the level of significance, and we're going to choose 5%, which is 0.05. And then step 4 is to extract all the relevant statistics. So what we have here is we have a group variable called training type 2, which is the U method. 1 is traditional, 2 is the U, 1 is traditional, and these are the actual scores for each of those. Okay, so with the Mann-Whitney test, then what we do first is we create a column called rank, and so we rank the values relative to one another. So we want to do a rank average value for D5, this number, compared to all the values in the data set. And if we do that, it comes out to be that the rank for this value here is 66, for this value it's 51, for this value it's 70. So you can copy that formula down to the last value in the data set, which is a rank average of 51. Okay, you'll notice there's quite a few shared ranks as well. Look, you see there's 0.5s. So you can see there's a number of shared ranks as well, etc. If you do a complete Excel solution, then you should take into account the shared ranks. Please note in this particular solution we don't, but SPSS, when we look at SPSS in solving this problem, it does. Okay, so what we do now is we create some summary statistics, relevant statistics. So we need the median for sample 1, we need the median for sample 2, and you can see in this case that we're using an array function, as you can see there. And then we calculate the number in group 1, the number in group 2, and then we can sum the group 1 ranks, which is T1, which comes out to be 1777, and we do the sum of the group 2 ranks, which we call capital T2, which is 3273. The mean of group 1 ranks is 45.56. The mean of group 2 ranks is 53.66. Then we can get T1 max, T2 max, and then we can substitute into these equations to give us U1 and U2. And then once we've done that, then our calculated value of U is the minimum value between U1 and U2, which is 997. So there's our equations there. We can do a quick check as well, because U1 and plus U2 should be the same as N1 times N2. So that plus that should give me that, which it does. Okay, now what we're going to do is we're going to do a normal approximation on this now using these equations here. So remember, this example's from the book. So we want the population mean, which is given by this equation here. It's just n1 times n2 divided by 2. The population standard deviation is given by this equation here. And then we can substitute that number plus that, plus the UCAL number, which is 997, into the equation for Z, such that ZCAL is minus 1.36. From that, we can also calculate a two-tail p-value using the norm.s.dist function, etc. Okay, and that comes out to be 0.1737. So our value, our two-tail p-value is 0.1737, which is larger than the 0.05. So in this case, we failed to reject the null hypothesis. So in other words, based upon the data collected, statistically, there's no evidence for any improvement in performance between the traditional and the U method, etc. Now, I've included how to correct the Z value there, but what I haven't done is I haven't included how do you correct for tied ranks. Now, remember, SPSS does that. Okay, so that's the end of today's movie. Bye for now. Remember, the book has the solution in detail. Okay, bye for now.